Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 1 video of the next chapter, that is direct and inverse proportion, uh, where I will discuss about in this video only direct variation between two quantities x and y, and what is the relationship between two quantities x and y when they vary directly with each other, and what are the formulas that we need to remember and we can use to solve problems. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Uh, uh, from this video onwards, I won't be streaming the webcam, because if I use the webcam, it is slowing down the machine uh, uh, largely, and I am and which is causing a great deal of problem in writing in with the writing software. So I'm sorry, I won't be streaming the webcam. So let's get started with the part 1 video on the chapter of direct and inverse proportion. Okay, so I have my quick, very rough notes prepared for this video. So in this video, we will discuss about what is about the direct variation of two quantities. Now, a lot of things is written. I will read them, and I will explain them. So please, it might sound very boring, but please bear with me. I will quickly go through the notes, and I will discuss the theoretical aspects, and then we will solve some problems which will clarify the concept. Okay, so the first thing is variation. What do we mean by two quantities x and y? They vary. So two quantities x and y are said to be in variation if changing the value of one variable, that is changing the value of x, that is not variable, quantity. If changing the value of quantity x brings a change in the value of the quantity y, and vice versa. So if you change x, y will change, and if you change y, x will change. If this happens, if this relationship exists between the two quantities x and y, then we say that the two quantities x and y vary with each other. Now there are two types of variation we will discuss. The first one is direct variation. The symbol used, this is the symbol of variation. So when we say that x, so by this we mean that the quantity x and y vary with each other, but specifically when we write this x, so this symbol is varies. So we say that in words we say that x varies with y, or x varies directly with y. Now, so this symbol is the symbol of variation. Now there is another kind of variation which is inverse variation. We denote inverse variation with so if x and y are if x and y are in inverse variation, then we symbolically, mathematically write it as x varies as 1 by y. Since 1 by y is the inverse of y, so that is the reason to mathematically represent that x and y vary inversely, we write it as x varies as 1 by y. So in this video we will only discuss about direct variation. Now direct variation is also known as direct proportion. Direct proportion. Okay. Now what is the relationship when we say that the two quantities x and y are in direct variation? What do we mean? How do the values of the x and y behave when one changes? So there are main 3 points, as you can see. So if you increase the value of x by this symbol, I mean, so you can say upper arrow. By upper arrow I means that if you are increasing the value of x, this will imply that the value of y will also increase. Now, so this means that the first point actually combines two points. The first one is that if you increase the value of x, then the value of y will increase. Similarly, if you increase the value of x, it will also imply that the value of, if you increase the value of y, it will imply the value of x will also increase. So if you combine these two, combining these two results, we can say that x, when you increase x, y will increase, and when you increase y, x will increase. So this is using the double implication. This is double implication, where we have the arrowhead on both the sides, and these are single implication. Okay, so when x increases, y increases, and if y increases, then x increases. Okay, similarly, if you decrease the value of x, by this symbol I mean the value is decreasing, that is, if you decrease the value of x, quantity x, then the value of quantity y will also decrease. Similarly, if you decrease the value of the quantity y, it will also mean that the value of the quantity x will decrease. So we have double implication. Now, it has been observed that it has been also observed that two quantities x and y are in direct variation. If they are in direct variation, then the ratio x by y, this ratio x by y is always a constant. That is, if you consider corresponding values of the two quantities x and y. So let's say x1 and y1 are the corresponding values of the quantity x and y. Similarly, let's say x2 and y2 are corresponding values. Then all the ratio x1 by y1 and x2 by y2, they will all be same and will be equal to a constant k. So k will be same. So k is same for k is the value, k is the constant, and it will be the same for the ratio of all the corresponding values of x and y. Now this constant k is known as the constant of proportionality. And it depends on the relationship between the quantity x and y. Now, depending on the real life scenario, quantity x and y will change, will be different, and so they will have a different relationship, and hence the constant k will be different. But for any two quantity x and y, if they vary directly or if they are in direct variation, and then if you consider any specific value of x and its corresponding specific value of y, then its ratio x by y will be a constant k. Now remember one thing, please note one thing, when we are saying that x by y is a constant, I can also say that y by k will also be a constant, y by x will also be a constant. Of course, it will be 1 by k, but since k is a constant, then 1 by k will also be a constant. So it does not really specifically say that the ratio x by y will be a constant. The ratio y by x will also be a constant. That is, the ratio of the two quantities x and y will be a constant. Now, whether you consider it as x by y or y by x, it does not matter. So x1 by y1, x2 by y2, they will all be the same constant value. Similarly, y1 by x1 and y2 by x2 and y3 by x3, they will all have the same constant value. Okay, so this is basically the fundamental concepts of two quantities when they are in direct variation, and the relationship between the two quantities, and the result that x by y, the ratio of the two quantities x and y, is a constant. So this is super important for solving problems. So if you have, so this formula, specifically this result, that is x1 by y1 is equal to x2 by y2 is equal to x3 by y3, will be all equal to the same constant k, where x1 and y1 are corresponding values of the two quantities, are one specific values of the two quantities x and y. Similarly, x2 and y2 are some another specific value of x and y. That is when x2 is the value of x, then its corresponding value of y is y2. Similarly, if x3 is the value of x, then its corresponding value of the quantity y is y3. Okay. Now let's discuss about some examples from real life of two quantities that vary directly or that are in direct variation. So I have A, B, C and D, four examples. Now there are numerous other examples that you can look out in your textbook. Now there are, while you will solve problems, you will see, you will come across these kind of many examples from real life. I have only considered four examples for the sake of discussion. Okay. So the first one is articles and cost. So you purchase articles from a shop or from online. So an article has a cost. So if you consider the quantity x and y such that x is the number of articles and y is the cost of those number of articles, then definitely if you will see that y by x is a constant. Now what is y by x? Y by x is cost per article. So if you are considering, let's say, an article, say if you are considering, let's say, a particular book, then of course if y is the cost of x number of books, then y by x will be the cost of one such book, and the cost of one such book will always remain constant. So here the constant k is nothing but the cost of one article. So in this example, as you can see, the ratio y by x is constant. Now of course the x by y will also be a constant. In that case, x by y will be 1 by k, and since k is a constant, so 1 by k is also a constant. Now, so this constant k has a specific meaning for the specific quantity x and y. For this example, where x is representing the quantity, x is representing the number of articles. Now this article could be anything. It could be a book, it could be a phone, it could be any article that you purchase from a shop or from online website, e-commerce website. So depending on, so the constant k will have a special meaning depending on what quantity x and y are representing. In this example A, x is representing the number of articles and y is representing the cost of articles. So we can clearly understand that y by x will be, the ratio y by x is nothing but the cost of one such article. And of course we know that the cost of one article will always remain the same. Okay. So the next example is a car traveling at an uniform speed. Now, if a car is traveling at an uniform speed, means the speed is not changing. While it is traveling, it is moving, its speed is the same. Now, in such a scenario, if you consider the two quantities x and y such that x is the distance covered by the car and y is the time taken to cover the distance, then the ratio x by y is nothing but the uniform speed of the car. Now the uniform speed of the car is constant. Since the speed of the car, a uniform speed means its speed is not changing, so it is constant. So for all values of x and y, the ratio x and y will be the same and it will be the uniform speed of the car. Okay. The third example is the calculation of simple interest when the rate of interest per annum, that is R, and the time period T is fixed. It is R and T are not changing. If you keep the R and T fixed, then the calculation, then the value of simple interest and the principal, they will be in direct proportional variation. So in this example, the quantity x and y are representing the quantity x is representing the simple interest, that is simple interest for at a fixed rate of interest R per annum and a time period of T, and y is the quantity y is representing the sum or the principal, that is P. Now from the concept of simple interest, you know that the simple interest, the formula is PRT by 100, where P is the principal, R is the rate of interest per annum, and T is the time period. So X will be Since x is representing the simple interest, we will have x is equal to SI, which is equal to PRT by 100, which is equal to again YRT by 100, because y is representing the sum or principal. So from here we get x by y is equal to RT by 100, which will be a constant since the R and T is fixed. R and T is not changing. Hence RT by 100 is a constant K. Okay. So the next example is selling price and amount of bill for a fixed percent VAT. So this is regarding, this concept is from the profit and loss. So when you purchase some product or an article from the shop, sometimes there is a, not sometimes, usually there is a VAT. That is a VAT, or it is sometimes also referred to as sales tax. Now this VAT, it has a percentage, VAT percentage. This VAT is applied on the selling price of the article, and that VAT amount is added to the selling price to give the final bill amount. So if you consider the quantity X to be the selling price of an article and the quantity Y to be the amount of bill, then, and also we assume that the VAT percent is fixed. Let's say it is percentage VAT. So let's say it could be 12%, it could be 18%, 15%, whatever. It usually depends on the article. So the percentage VAT is fixed. If it is fixed, then we know from the concept of sales tax and selling price that the bill amount will be equal to Y, since the Y is the quantity Y is representing the amount of bill. So bill amount is Y, which is conceptually is equal to the selling price plus the amount of VAT, which is calculated based on the percentage VAT and the selling price. So the amount of VAT is percentage VAT of SP. So we have SP plus percentage VAT by 100 multiplied by SP, which is equal to 100 plus percentage VAT by 100 multiplied by SP. Now what is SP? The quantity X is representing the selling price of the article. So we have Y is equal to 100 plus percentage VAT by 100 multiplied by X, and hence we get Y by X is equal to 100 plus percentage VAT divided by 100, which is a constant since the percentage VAT is a constant, it is fixed for a particular article. So if the cost of an article is more, obviously, so if the cost, that is the selling price of an article, is more, that is if X is more, then definitely the amount of bill Y will also be more. Okay, so these were 4 examples of 2 quantities that vary, that are in direct variation, or they vary directly with each other. Okay, now let's try to solve few problems. Some problems are directly taken from the textbook of author R.S. Aggarwal, and some are from other sources. Now, please note that from now onwards, for every video, I will prepare a set of homework problems which is based on the concept that has been discussed in a particular video, and the link of the PDF of the homework problems I will attach in the description below. So while video is uploaded, you may not immediately see the link of the homework problems, but please keep an eye on the description of a particular video. You will eventually see the link of the PDF of the homework problems in the description. So immediately when I upload a video, I may not be giving the link, but sometimes later on, after creating the homework problems, I will edit the description section of the video and will give the link. Okay, so let's solve a few problems to understand how we can apply the concept of 2 quantities in direct variation. Okay, so the first problem says that if X and Y are directly proportional, or it also means that the quantity X and Y are in direct variation or in direct proportion, find the values of x1, x2 and y1 in the table below. So as you can see in this table, there are some values of x and y, corresponding values of x and y are given. So from the first column, you can see that when so we can see that when x is 3, y is the value of y is 36. We know that we will apply the concept of that the ratio of x and y. You can either consider the ratio x by y or y by x as a constant. So if I consider the ratio x by y to be constant, I must have from the table that 3 by 36. So this is the ratio of the corresponding values of x and y from the first data. This should be equal to x1 by 60. This should be equal to x2 by 96, and this should be equal to 10 by y1. We are applying the concept that we discussed, that this concept, if we have, so x1 by y1 is equal to x2 by y2 is equal to x2 by 3, you can also write this result as y1 by x1 is equal to y2 by x2 is equal to y3 by x3. It will make no difference in solving the problem. Okay. So I am considering the ratio x and x by y. So I must have this. Now as you can see that from this result, I will immediately get the value of x1. So from this I will get the value of x1 is equal to, using, so 3 by 36 is equal to x1 by 60. So you can consider this is a linear equation in x1, the unknown x1. So from this equation I can find the value of x1 to be 60 multiplied, using cross multiplication, 60 multiplied by 3 divided by 36, which is equal to, if you simplify this, 6 10 6 6 2 5. So this is equal to 5. Okay, so x1 is 5. Okay, now also I will have that 3 by 36 is equal to x2 by 96. From here I can also calculate the value of x2 as x2 will be equal to 96 multiplied by 3 divided by 36. This is equal to 3 cancels 36 with 12, and 12 cancels 96 with 8. So this is 8. So x2 is 8. Okay. Also we have 3 by 36 should be equal to 10 by y1. So this implies y1, using cross multiplication, y1 will be equal to 10 multiplied by 36 divided by 3. So this is equal to 120. So we have x1 equal to 5, x2 equal to 8, and y1 is equal to 120. So this is a standard pattern of question where you will be given a table of x and y, quantities x and y, which will be given to be vary directly. That is, the quantities x and y are in direct variation. You will be given a table where there will be some unknown values of x and there will be some unknown values of y. That is, for this problem, the unknown values of x were x1 and x2, and the unknown values of y to be found is y1. So using the concept of x1 by y1 is equal to x2 by y2, using this result, you can very easily find the unknown values. Okay. Let's do the next problem. Now this problem says that from the following table determine whether x and y are in direct variation. So in this time, this problem has two parts. So we are given a table of x and y values. It is not given, it is not said that the two quantities x and y are in direct variation. We have to find out, we have to verify or find out whether the quantities x and y are in direct variation or not. So for this table, if for this table, first of all, uh, we must have, let's see, if x and y are, so let's say, so we will find the ratio of x by y for all the corresponding values. So what is the ratio x by y for the values 4 and 24? So this is 1 by 6. Okay, now so what is the ratio x by y for the second set of values, that is 7 by 42? This is also equal to 1 by 6. So far, we can say that x and y vary directly, are in direct variation, because the ratio x by y are are all the values of x, the ratio x and y are coming to be equal to 1 by 6. Now, lastly, the ratio x by y for the third corresponding values, or the third set of values, is 10 by 60, which is also 1 by 6. So we are having the ratio, all the values of all the ratios are same. Hence, we can say that the two quantities in this example, in this table, the two quantities x and y are in direct variation. Okay, let's see the part 2. For the x by y, uh, x by y, if we consider the ratio x by y. Now, just for the sake of fun, let's say for this problem part 2, we are considering the ratio y by x. So for the first set of values, that is the first corresponding values, y by x is 1.1 by 1. This is equal to 15 by 10. This is equal to, after simplification, 3 by 2. So the constant k is 3 by 2, not constant, but the ratio y by x for the first set of value is 3 by 2. Now, so let's see what is the value of y by the ratio y by x for the second set of values. It will be 6 by 4. If you simplify this, this is also 3 by 2. So far, we can see that the values of the ratio y by x are all equal to 3 by 2. Okay, let's see the ratio y by x for the third set of values, that is 13.5 by 9. This is equal to 135 by 90. Now, let's 45. Let's divide by 5. This is 5, 118. This is 5, 27. And this is, okay, so 3, so if you divide by 9, this is 2 and this is 3. So this is also 3 by 2. So as you can see, the values of the ratio y by x for all the corresponding values of x and y are coming to be the constant 3 by 2. So hence, for the part 2 also, the quantity x and y are in direct variation. So you can say this is in direct variation and this is also in direct variation. Okay, let's see the next problem. Now these are what problems? The most problems in the, for solving most problems of the chapter or direct and inverse variation will be what problems. So it says that and it is so for solving word problems, it is very important and crucial to understand the two quantities x and y and whether they are in direct proportion or uh, inverse proportion. So some of the quantities, it will be very obvious from common sense. You should be able to figure it out whether the two quantities x and y, depending on the given problem, they are in direct proportion or in inverse proportion. And also you have to solve a lot of problems to uh, so that you are confident enough to decide whether the two quantities x and y involved in the given problem, they are in direct proportion or inverse proportion. Okay. So if 25 meter of cloth costs rupees 337.50, then what will be the cost of 40 meter of same type of cloth, and what will be the length of the cloth bought for rupees 110? So the two quantities, as we can see, if I say the quantity, if I consider the quantity x to be the length of cloth. Now the cloth is of same type. So whenever it is given that what will be the cost of 40 meter of same type of cloth. So if so we are talking about a specific or the same type of cloth, that is the quality, that is the quality of the cloth is same. So if we consider x to be the length of cloth and y to be the cost of x meter, let's say the length of cloth in meters, and y to be the quantity which is the cost of x meter of cloth. Now from common sense we can clearly say that y will vary, x and y are in direct variation. That is, if you increase the length of the cloth, the cost of the cost will increase, and if you decrease the length of the cloth, the cost will decrease. That is, for a larger length of cloth the cost will be higher, and for a smaller length of cloth the cost will be lower. So we can clearly see that y is proportional, is y and x are directly proportional, are in direct variation. You can mathematically say say that using this symbol, that is y varies directly as x, or you can also say x varies directly as y. These two means the same thing. Now usually when we write this, that is x varies directly with y, we mean that x by y is a constant. The ratio x by y is a constant, which is a k. And when we say that y varies directly as x, we usually means that the ratio of y by x is the constant, even though in both the cases the fundamental concept is that the ratio of the two quantity x and y will be the same. Now it does not matter whether you are considering x by y or y by x, it will be the now x by y, all the corresponding value, for all corresponding values of x and y, x by y will be the same constant value, and for all the corresponding values of x and y, the ratio y by x will be some another constant value. Okay. So in this example, now we can say that uh, for solving the part 1 problem, it is the problem has already given that 25 meter of cloth costs rupees 337.50. Now let's try to solve this problem, in a tabular fashion. Right? Let's try to solve both the parts, part 1 and part 2, using a table. So if we consider the two quantities x and y, so x, from this information we get that the length is 25. Now all the length are in meters and all the costs are in rupees. So if x is when the value of x is 25, that is 25 meter of cloth, the cost is given to be 337.50. Let's tabulate another set of values. Let's say we if we assume that what will be the cost of 40 meter of same type of cloth, let's say we are assuming the cost of 40 meter of cloth will be x1, and for so we can tabulate, so we can say, so if we are assuming, so let's say for part 1, let 40 meter cloth costs rupees x. So this is the one assumption we are making. Another assumption we are making is that for solving the part 2, it is asking that what will be the length of the cloth bought for rupees 810. So let's say, let y meter of cloth cost rupees 810. So we have three data. By data I mean corresponding values of x and y. The first data is given in the problem itself, that is 25 meter of cloth costs rupees 337.50. We have already written that in the table. The second data is coming from the assumption that we are assuming 40 meter of cloth cost rupees x. So cost rupees not x but rupees x1. So as per the assumption that the 40 meter of cloth cost rupees x1, we are having this set of data. And again, we are assuming that let not y meter but y1 meter of cloth cost rupees 810. So we will have y1 over here and 810. Now in the second set of data, I think I did some mistake. No, it is fine. Sorry, I'm using wrong notation. Let 40 meter, all the unknowns for the quantity x should be named as x1, x2, x3 like this, and all the unknown values of the quantity y should be named as y1, y2, y3. So I did a mistake. So let 40 meter cloth costs rupees, this should be y1, and let x1 meter, let x1 meter of cloth cost rupees 110, x1. So we have over here, so this will be y1, this is y1, and this will be x1. So we have this data. Now since we know that the quantity x and y are in direct variation, we must have from the table 40 by y1 should be equal to 25 by 337.50. We are considering the ratio x by y. Now from this we can easily find out what is y1. It will be 337.50 multiplied by 40 divided by 25. This is equal to, let's find out what is, so this is equal to 3375 multiplied by 4 divided by 25. This after simplification becomes 25 cancels 3375 with 1, and 887, 375, 5, and this is equal to 135 multiplied by 4 is 20, 14, and 540. So y1 is 540, and y1 is, we have considered y1 as a cost of x meter of cloth. So this will be rupees 540. So y1 is rupees 540. Now we have to find x1. Now we can find x1 from the fact that now since we can write we must have x1 by 810 is equal to 25 by 337.50. This should be also equal to 40 by y1, and y1 we have already found to be 540. Now you can equate this to find x1. You can equate this to, or you can also equate this to, whichever you find convenient. I will use the second one. I will use this one. So I have x1 by 810 is equal to 40 by 540. So this implies x, by using cross multiplication we get x1 is equal to 40 multiplied by 810 divided by 540. This is equal to 0 cancels out, 9 6 9 9 2 3 sorry 3 2 3 3 2 2. So this is equal to 60. So x1 is the quantity x is length of cloth. So this is 60 meter. X1 is 60 meter. So we get for the first problem. So the answer will be for part 1. For part 1 it was asking what will be the cost of 40 meter of cloth. So the cost of 40 meter of cloth is y1, which is rupees 540. And for part 2, the part 2 was asking what will be the length of the cloth bought for rupees 810, which is x1, and x1 is found to be 60 meter. So 60 meter. So these are the answers. Now it is highly possible that I am doing some calculation mistake and my results or my answers are coming wrong. So that is a possibility. I am not really focusing in that. Please focus in the concepts I am applying to solve the problem. Now I forgot to pause. So after I will solve a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Okay. Okay. Let's do problem number 4. This is also a very standard variation of problem, and the concept is about the height of an object. So the concept is that at a specific time, uh, that is when the position of the sun, when the sun is at a specific position, the ratio of the height of any object and its shadow casted by the sun is a constant. The key concept is that the time has to be the same. That is, if you the ratio at a specific time, that is when at a specific position of the sun, if you consider the ratio of the ratio of the height of any object and its casted shadow, this ratio for any objects will always be the same. Now that object could be a pole, that object could be a tree. So at a specific time, the ratio of, let's say, of a pole, the ratio of the length of the height of the pole and the length of its casted shadow, this ratio will be equal to the height of a tree and the ratio of the height of a tree and its casted shadow. So this is the concept. So in this problem it is saying that at a particular time, so it is talking about a particular time, that is so this ratio, the ratio which is a constant, will depend on the particular time, and this constant will vary over at different times or at different position of the sun. This constant will change. But at a specific time, this constant will be the same for all objects. That is the ratio of the height of the object and its casted shadows and its casted shadow. That ratio will be same for all objects at a specific time. So it is given that at a particular time, the length of the shadow of Qutub Minar, whose height is 72 meter, is 80 meter. What will be the height of an electric pole? The length of whose shadow at the same time is 1000 centimeter. So if you consider the two quantities x and y, let's say x is the height of an object and y is the length of casted shadow. Now you could also, now it does not really matter whether you are considering x to be the height of an object or the length of the casted shadow. It could be other way around. It will not matter. So I am considering the quantity x to be the height of an object and the y to be the length of its casted shadow, and these are all definitely at a specific time. So now if I try to create a table of data of x and y, I try to create a table based on the given information. It is given that for regarding the Qutub Minar, the height is 72 meter. So 72, so x is in meter. So both x and y are in meter. Let's say both x and y are in meter. We will consider both x and y are in meters. So it is about the Qutub Minar. It is given that the height of the Qutub Minar is 72 meter, and at that particular time, the length of its casted shadow is 80 meter. So we have the data 72 as x and 80 as y. Now the question is, what will be the height of an electric pole, the length of whose shadow at the same time is 100 centimeter. So we assume let height of pole be x. Since we are representing x as the height of the object, so we will name the unknown, that is the height of the pole, to be x1 meter. So we can add another data in this table, which is x1, and the length of the shadow for the pole is given to be 1000 centimeter. Now 1000 centimeter, so 1000 centimeter, since we are considering x and y all in meters, so 1000 centimeter is equal to 1000 divided by 100 meter. This is equal to 10 meter. So we have 10. Okay, so now we know that the quantity x and y are in direct variation, because this concept that the height of an object and the length of its casted shadow, they are in direct variation. So if the height of the object is more, then the length of the casted shadow will be more, and vice versa. That is, if the height of an object is less, then the length of the casted shadow will also be less. But please remember that the constant of proportion, that is x and y, that is for a specific time. That is, the constant is for a specific time, and if you change the time, that constant, the ratio, that is x by y, will change. Okay, so now from the concept of two quantities in direct variation, we can say that 72, we are considering the ratio x by y. You can also consider the ratio y by x, it will not matter. So let's say 72, we must have 72 by 100 is equal to x1 by 10. So this implies x1 is equal to, from cross multiplication we get 72 multiplied by 10 divided by 100. So this is equal to 7.2 meter. Oh, I'm sorry. This is not 100. This is 80. This is 80. Okay. So we have x1 is equal to 72 multiplied by 10 divided by 80. So 0 cancels and 8 cancels, 72 with 9. So this is 9 meter. So the length of the height of the pole is the height of the electric pole is 9 meter. So as you can see, it is very crucial and very important to understand how the given quantities are, how they are related. Are they varying with each other? Are they in direct variation or in inverse variation? Now, in the next video, theoretical video, I will discuss about inverse variation. Okay, let's do the next problem. Okay, so this is also a very typical problem, and so the problem says that the scale of a map is 1 is to 3 multiplied by 10 to the power 7. Two cities are 5 centimeter apart on the map. Two cities are 5 centimeter apart on the map. Find the actual distance between them in kilometer. Now, what does it mean that by the fact that the scale of a map is 1 is to 3 multiplied by 10 to the power 7? Now, scale is 1 is to 3 multiplied by 10 to the power 7 basically implies that, so if you consider, it basically implies that now if I consider, now since the map, the scale, the units of measurement for the map is in centimeter, and of course in the real life the distances of two cities are of course in kilometers. So if we consider the distances in the real life in kilometers and the distances between two cities in the map in centimeters, this the scale is 1 is to 3 multiplied by 10 to the power 7 means that 1 centimeter in map is equal to 3 multiplied by 10 to the power 7 centimeter in real life, which is equal to 3 uh, centimeter. It is given in centimeter. So the scale is 1 is to 3 multiplied by 10 to the power 7 means that 1 centimeter in map it will be equivalent to, so this is a concept of ratio. So 1 centimeter in map is equivalent to 3 to the power 10 to the power 7 centimeter in real life. Now this is equal to centimeter. So let's convert 3 multiplied by 10 to the power 7 centimeter in kilometers. We divide by 100, so that becomes this amount of meter, and then we divide again by 1000, so this is kilometer, which is equal to, in the denominator we have 10 to the power 5, so 10 3 into square kilometer in real life. No real life. Now the what is the, so how do we apply the concept of two quantities in direct variation to solve this problem, now so let's say, let so it is asking, the question has asked find the actual distance between them in kilometers. So uh, actual distance let actual distance be uh, let actual distance be y, kilometer. Now, first we have to identify the two quantities x and y. We have to identify the two quantities x and y. So let's say the quantity x is distance in map and the quantity y is distance, let's say we call it actual distance. Actual distance. So the distance in map means the distance between two cities in the map. Let's x, the quantity x represent the distance between two cities in the map, and let the quantity y represent the actual distance between the two cities in the actual distance between the two cities in the real life. Now, as you can see that if definitely the quantities x and y are in direct variation, because if x is more, then definitely it means that uh, the actual distance will also be more. Now, one thing, this data is very crucial, is very important. So you can consider this ratio 1 is to 3 multiplied by 10 to the power 7 as the ratio x by y, which is a constant. So for this problem, the constant that k that we have discussed in the discussion of two quantities x and y are in direct variation when the ratio is always a constant, that is x by y is a constant k. So that constant k for this problem is is 1 by 3 into 10 to the power 7. So if we consider x to be the distance in map, and let's say x to be the distance in map in distance in map um, distance in map in centimeter, and let's say we are representing the quantity x to be the distance in map in centimeter, and also y to be the actual distance in let's say um, actual distance in centimeter. So we can see that since the scale, what does the scale means? The scale means that 1 centimeter distance in the map will be equal to 3 into 10 to the power 7 centimeter in the actual distance. The actual distance will be, so it means that for 1 centimeter in the actual distance of 1 centimeter in the map will be equal to 3 multiplied by 10 to the power 7 centimeter. So now if we try to create a table, x and y, where let's say, so we have assumed that the actual distance of the actual distance be y kilometer, let's not say y kilometer, but let's say y centimeter. That is, we are assuming that the actual distance between the two cities is y centimeter, whose distance in the map is given to be 5 centimeter. So now we can say that the first data, while creating the table, the first data I can say x will be 1 and y will be 3 multiplied by 10 to the power 7, because it is given that the scale of a map is 1 is to 3 multiplied by 10 to the power 7. This essentially means that it has already given a data, that is 1 centimeter in the map will be actually, its distance will be 3 multiplied by 10 to the power 7. So I can, as the first data in the table, I can say I can have 1 as x and 3 multiplied by 10 to the power 7 as y. Now for the second data, I will consider, since x is the distance in map, the second data will be 5 and the y will be, the let actual distance be y1. So we have y1. It is asking to find the actual distance of two cities whose distance in the map is 5 centimeter. So for the second data, we are having the value of x as 5 centimeter and the value of y as y1 centimeter, and y1 centimeter is as per our assumption, because we have assumed that the actual distance of the two cities is y1 centimeter, whose distance is given in the map to be 5 centimeter. Now we will apply the result, that is the ratio is constant. Ratio of all corresponding values of two quantities x and y which are in direct variation will be same. That is, we will apply from the fact that x by y is a constant, will imply that 1 by 3 multiplied by 10 to the power 7 will be equal to 5 by y1. Now it is very important that we have assumed both the quantity x and y to be distances in centimeter. Okay, so we have this. From here we can solve y1 is equal to 5 multiplied by 3 multiplied by 10 to the power centimeter, this much centimeter. Now the problem has asked to find the actual distance in kilometer. Okay, so this is 15 multiplied by 10 to the power 7 centimeter. This is equal to 15 multiplied by 10 to the power 7. If I divide by this whole, 15 multiplied by 10 to the power 7 is in centimeter. If I divide by 100, I get in meter, and then again if I divide by 1000, I get kilometer. So this will be this much kilometer, which is equal to, after cancelling the powers of 10, we get 15 multiplied by 10 square kilometer. So this is equal to 1500 kilometer. So the actual distance between the two cities is 1500 kilometer, whose distance in the map is 5 centimeter. Okay. Okay. Let's do the next problem. I hope this is the last problem. Okay. This problem is not a word problem, but this is more of testing the fundamental concepts of two quantities in direct variation and applying the fact that the ratio of two quantities x and y which are in direct variation, it is a constant. We have to apply that concept. So the problem says that if x and y are in direct proportion, then find whether the following quantities are in direct proportion or not. We have to, there are 4 parts. Okay, so we are given that x and y are in direct proportion. Now, so if x and y are in direct proportion, we will always have x by y, or you can consider y by x, does not matter. I am considering x by y will be a constant k. Okay, now so since x varies directly with y, which means that, so this is a mathematical notation of saying that the two quantities x and y are in direct variation. We can say that x by y is a constant k. Now we have to see whether the quantities x minus 1 and y minus 1, whether they are in direct variation or not. Now let's see, from the fact that x by y is a constant k, we can say that x is equal to ky. We have this x is equal to ky from this fact that the ratio x by y will be a constant, since the quantities x and y are in direct variation. So we can say that x is equal to ky. Now let's see, now the quantities x minus 1 and y minus 1, they will be in direct variation only when x minus 1 divided by y minus 1 will be a constant. So what is x minus 1 divided by y minus 1? This is equal to x, from the previous fact, we know that x is equal to ky for some constant k is some constant. So x minus 1 divided by y minus 1, we can say, we can rewrite this as, substituting the value of x as ky, we can say this is ky minus 1 divided by y minus 1. Now, you cannot, as you can see, this expression is not a constant. This is not a constant. You cannot express the this rational term, that is ky minus 1 divided by y minus 1. You cannot express this as a constant. It is not a constant and is dependent on y. As you can see that this expression, now if the quantities x minus 1 and y minus 1, if they are in direct proportion, then we must have the ratio x minus 1 divided by y minus 1, it must be a constant. But we can see that x minus 1 divided by y minus 1 is coming to be ky minus 1 divided by y minus 1, which cannot be expressed as a constant. It's not a constant and is dependent on y. So this implies x minus 1 and y minus 1 are not in direct variation. Are not in direct variation. Okay, let's see what is, let's see part number 2. The quantities are, so as usual, since x and y are in direct variation, we will have x by y is some constant k. So this will imply x is equal to ky. Now we, to check whether the very quantity 2x and 3y are in direct variation, we will find what is the value of the ratio 2x, the ratio of the two quantities, that is 2x and 3y. If this expression, if the value of 2x by 3y is coming to be a constant, then we can say that the quantity 2x and 3y are in direct variation. Now this is equal to, from this we get 2x can be written as the value of x is ky, from the fact that x and y are in direct variation and x by y is equal to k, where k is some constant. So we can say, we can substitute x as ky and we have 3y. Now this is equal to, the y gets cancels out and we have 2k equals to 3. This is equal to k1, a constant. Now why 2k by 3 is a constant? Because k is a constant. So if k is a constant, then of course if you multiply a constant k with another constant, then the result is also a constant. So k is a constant. So if you multiply k with 2 by 3, so 2k by 3 will also be a constant, but it will be a different constant, and that different constant we are considering as k1. So k1 is also a constant. So we can see that the ratio of the quantity 2x and 3y is a constant. So this implies that 2x and 3y are in direct variation. So this is not in direct variation, this is in direct variation. Let's see part 3, x square and y square. So as usual, since x and y are in direct variation, we can write x by y, a constant k. So this implies x is equal to y k phi. Now to see whether x square and y square are in direct variation or not. Let's see what is the ratio between the two quantities, that is x square and y square. Now x square, we can rewrite it as k y square, and we have y square. This is equal to k square y square by y square. Y square cancels out. This is equal to k square, which is of course a constant. We are representing, let's say, the constant, that let's say k2, k square is k2, which is also a constant. Since k is a constant, then of course, if k is a constant, then k square is also a constant, but it will be a different constant. So for the part 2, you can see that 2k by 3 is k1. So for all corresponding values of the two quantities 2x and 3y, the ratio will be, that is the ratio of 2x and 3y will be k1, which is essentially equal to 2k by 3. And what is k? K is the constant of the ratio between the quantity x and y. So for part 3, we can also see that the two quantities x square and y square, they are also in direct variation, as we found that the ratio of the quantities x square and y square, that is x square by y square, is coming to be a constant, which is k square. Now why k square is a constant? Because k is a constant. And what is k? K is the constant of proportionality of the two quantities x and y. Okay. Let's see the part 4, which is 1 by x and 1 by y. So as usual, we have, since x and y are in direct variation, we have x by y will be a constant k, let's say, and from here we will get x is equal to ky. Now we have to check whether the two quantities 1 by x and 1 by y are in direct proportion or not. So let's see what is the ratio of the two quantities, that is 1 by x divided by 1 by y. If this value turns out to be a constant, then we can say that the quantities 1 by x and 1 by y are in variation. So this is this, if you simplify, is 1 by x multiplied by y by 1, which is equal to y by x. And this is equal to, now this is a straightforward question. If you know, if the two quantities x and y are in direct variation, we know that the ratio x by y will be a constant, and which also means that the ratio y by x will also be a constant. But the constant, definitely the constant value of x by y and y by x, they are not same, they are reciprocal to each other. So we are having y by x will be definitely equal to 1 by k. Let's say this be equal to k3, which is a constant. K3 is a constant because k3 is equal to 1 by k and k is a constant. So this implies that 1 by x and 1 by y are in direct variation. So that is all for some illustrative problems. Now I will of course solve the problems of the textbook of exercise 12A from the textbook of author R.S. Aggarwal in a separate video, which will be uploaded very soon in the same playlist. And also when I will upload this video, it instantly I will not provide the link of the homework problems, the link to the PDF file of the homework problems, because I have not yet prepared it. So as of now, I will not provide any link to the homework problems. But please keep an eye on this video. Please check back later. Let's say within 24 hours, I will definitely provide the link of the PDF of the homework problems based on this video, that is based on direct variation. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. So the two upcoming videos will be on the first I will for the first I will prepare the homework problems for this video, that is on variation, that is on direct variation, and I will also prepare the solution video for the homework problems on direct variation, and then I will prepare a video in that will be regarding solving the problems of exercise 12A from the textbook of author R.S. Aggarwal, which is based on the direct variation, and then we will move on to discuss the next topic, that is inverse proportion or inverse variation. So please stay tuned for the upcoming videos. So thanks for watching, and until the next video, take care and bye.